Welcome once again to Maths with a Subnormal. In our today's tutorial, we will be solving this Maths Olympiad problem. Our goal here is to provide the value of x that will satisfy this initial equation. Okay, we are given that 3 to the power of x minus 2 to the power of x is equals to 65. Let's work out the value for x. But then our main goal to solve this, since they are not of the same base, that's we have 3 here, it is not the same as what? 2. So all we have to do is to find a unique technique to solve this problem. So the first technique we'll consider is trying to make each of these terms, or each of these terms that have the power x, to be in quadratic form. So to do that, let's say we have 3 to the power of x. Okay, if I decide to raise this to the power of 2 over 2 now, 2 over 2 is 1, so nothing changed. If you agree with me on this, you can now see that because 2 divided itself is 1 and anything multiplied by 1 is 1. In that case, I can now reform it to gain that my quadratic as 3 to the power of x over 2, then all squared. If you agree with this, because these 2 can still cancel out, these 2 can still cancel out, hence nothing changed. So I'm going to apply it to the 3 power x and also apply it to the 2 power x. Let's apply it and see how it will look like. We have 3 to the power of x over 2 all squared, then minus 2 to the power of x over 2 all squared is equal to 65. Good. We've gotten a quadratic form because we have a square here, these 2 squares. Okay, then the next thing we have to do is that we observe these terms. Now these terms are quite in a quadratic form, so we can now write it in a unique way to help us find those values. So we can now say, assign it to be, let p be equals to the first term, which is 3 power x over 2, and let q be equal to 2 power x over 2 again. So now we have to substitute back the values of p and q in the initial problem. So if you substitute, we are having it as p squared minus q squared is equal to 65. Okay, on this, if you have this, you can now see that this middle term is clearly a difference of 2 squares problem. So if you apply difference of 2 squares, in difference of 2 squares, we agree that if you have a squared minus b squared, that is the same thing as a plus b into a minus b. The reason why we're trying to do this is just to expand the term. If that's agreed, we can now substitute it in this already existing equation. So if you try to substitute, you can now see we have it as p plus q into p minus q is equal to 65. Okay, since we have this now, recall that these 2 are multiplying themselves. So we can now do a little rearrangement in 65. We are going to, since these 2 are products, we are going to think of 2 products that multiplies 2 whole numbers that multiply themselves to give 65. Okay, so the numbers can be, but it must be in, if you look at this clearly, since this is a positive solution, it shows that p must exactly be greater than q. If you agree with this, you can now see that when we have p plus q in a bracket into p minus q, we cannot have it to be 65. If you do 13 times 5, you are getting 65. Okay? Because 13 times 5 is 65. And it's clearly that when you sum these 2, you are getting what? 13. And if you subtract these 2, you are getting 5. So we'll now we now apply simultaneous equation, comparing it to be that p plus q is 13 and p minus q is 5. So we have it that p plus q is equals to 13, and this will be equation 1, and p minus q should be equal to equal to 5, and this will be equation 2. So we have found two equations we are trying to solve. To solve this, we can actually solve this particular equation by elimination method. And to solve by elimination method, we just have to add the equation 1 and equation 2. So if you add equation 1 and equation 2, we will be having that p plus p is 2p. We have it as 2p, and this is equal to, because p minus p is 0. Hence, q minus q is 0, sorry. Hence, q is eliminated. And this is equal to 13 plus 5 is 18. Okay? So since we have 18, we will now have to divide through by 2 and divide through by 2. If you divide through by 2, understand one thing, that p is now equal to 9. So we've gotten p to be 9. So let's try to find the value of q. To find the value of q, we have to put back the value of p in any of the equation. Because of positive sign, let me choose equation 1. Equation 1 says that p plus q is equal to 13. And our p is 9. That means 9 plus q is equals to 13. To get the value of q, you see that q is equal to 9. Q is equals to 13 minus 9, meaning that q is equals to 4. So q is exactly 4 in this problem. Remember, what do we have initially as the value of our p? We defined p to be that p is equals to 3 power x over 2, and we defined our q to be equal to 2 power x over 2. So those are the two terms for p and q. If you understand well, you can now see that p is 9. P is 9. So 9 is equal to 3x over 2. Okay? So all we have to do now to get the value of x is just to square both sides. Okay? If you square both sides, what do we have? This will cancel out this, so that you can now see we have it as 3 power x is now equal to 9 squared is 81. Okay? So you can now see that 3 power x is equal to 81 can be seen. We have to express the left and the right hand side to be in common base so that we can equate the powers. So 81 can be seen as 3 to the power of 4, right? 3 times 3 times 3 times 3 is 81. So in that case, you see that here x is equal to what? 4. Good. Then x is equal to 4 here. Let's look at this value. You can now see that we have the q to also be our q. We got q to be 4. We have it that, let's check here, 4 is equals to 2 power x over 2. Okay, the first thing we have to do is to square both sides to eliminate that fraction in the power. If we square both sides, we have it that 2 power x is equal to 4 squared is 16. So 16 can be seen as 4 times 4 times 4 times 4. That means you see that 2 power x is equals to 2 power 4. This also confirms that x will only be 4. So x is 4 in this too. That means our statements are right, because x have to be the same in all the equation. Remember, the equation is 3 power x minus 2 power x is what? 65. Let's try to test. Let's test our solution to know whether it's right. Okay? So we got x to be 4. So we have to replace 4 in all the terms in the equation. So here we have it as 3 to the power of x is 4 minus 2 to the power of x is 4. Is it actually 65? Is it actually 65? So to check that, 3 power 4 is 3 times 3, 9 times 3, that is 81. 81 minus 2 power 4 is exactly 16. So let's know whether this is actually 65. So we have 81 minus 16. You have it as 1 minus 6 can work. We borrow 1. 11 minus 6 is 5. Okay, this is remaining 7. 7 minus 1 is 6. So 65. That means our solution is right for the value of x. This shows that x is equal to 4. If you found this video helpful, don't fail to like, comment, and share. Drop some problems you are facing so that we can tackle it in our next video. Don't forget to hit the like and subscribe button so that you're notified anytime I drop a new video. Thank you.